Hey guys, it's Reed here, and this is episode 20 of Contest Coding. Today's problem is called rounding to the nearest vowel, and what you're going to do is you're going to be given a letter and you have to round that up or down to the nearest vowel that comes next or right before it in the alphabet. So there's a couple different ways you can do this. The one that I'm going to use is just one that's pretty basic and easy to understand. What I'm going to do is I'm going to make sure I have a string key, which is going to be my alphabet. So I'm just going to have to type in A, B, C, D, E, F, etc. like that. So just type in your alphabet. Hopefully you don't make a mistake, but that's the only really way you're going to get a key is just having to type it in manually. So make sure you concentrate on that and you don't want to mess that up. Next, I'm going to have a v-index array, which is going to be just the indexes of all my vowels, which the first letter, the fifth letter, the ninth letter, the 15th letter, and the 21st letter are the vowels. So you're going to take one less than that to make it your indexes correct. So like so 0, 4, 8, 14, and 20. Those are your numbers that are going to correspond with the vowels. So A, E, I, O, and then U is 20. Next, we're going to take a string and we're going to get an index of the, and a way, right before I do that, a way you can do this really easy is you can just do key.index of, let's see, AE, and it will fill it in for you. You don't have to worry about any tricks of like having to go and count your vowel stuff. So that's just an easy way to do it. Depending on if you want it to look cleaner, you put the numbers and count it yourself. If you don't really care, you just add some extra methods in your initial code. Next, we're going to do vlets, which are the letters that correspond with these objects. And this is going to make it, or these strings, so A, we'll have A here, E, I. Now you could do characters, but I say it's probably better to do strings just because it's easier to work with when you're printing it out. You don't have to worry about anything. It doesn't really make a difference, but strings are easier to compare, so I'm just going to use strings. So now you have your basic, I guess you can say instance variables, but they're really not instance variables for solving the problem. What you're going to have to do first, get the location of the letter they give you. So we're going to get index of send.next. Just like that, and now we know T, and it's going to give us some number wherever T is in the alphabet, one before U, so it's going to be at index 19. That's the number we'll get for T. So what we're going to do now is we're going to have a smallest count equals, we'll say 10. 10, it can be any number you want as long as it's greater than the difference it's ever going to be. Looking at these numbers, showing that like the greatest difference is going to be like from like 14 to 8 is like 6, 20 to 8, 20 to 14, another 6. To me around 6, so you could even probably do like 7, it'd probably work. But I'll just take 10. It's a nice simple number and it will let you have your key value be extraneous. Now I'm going to have a wildcard or just a question mark for my string let, because that's going to be my null value that I'm going to start it with. It could really be anything. It could even be set to null. As long as you have it set to something, it will work out fine. So now what we're going to do to get this is we're going to do a basic for loop and cycle through all of the vowel indexes just to see if we have anything dot length like that. I++. We're cycling through all of our vowel indexes to see if one of them is the smallest, which one of them will be. We got to see which one it is. So we're going to say abs of the index I minus lock, which is the location of the vowel is less than smallest. So what this is saying right here is if, so we're going to start, we're going to get 0. Is 0 minus location of 19 less than smallest? No, so we know it's not the right one, so we just keep going, skip it. If it is less than the smallest one that we currently have, we're going to know, let's see, we have to store that and we have to keep checking. So we're just going to say smallest equals the difference. Why am I using a string there? We'll reverse it now because it really doesn't matter when you do absolute value. And we're going to say the letter for that is going to be equal to the vlets at I. Now we get out of there, and now we have to print out is the letter. So pretty simple. We'll make sure this works, compile it. No compile errors, and we get rounding. We get U, E, and A. Those are the correct answers, and that's how you do it. So this is somewhat more confusing than it could be, but it really is just an easy way to do it quickly. Having a key, having your indexes, you can make this some sort of dictionary thing to make it more efficient possibly, or cleaner. It really doesn't really need to be, because it's just simple. You have 5 letters you're checking, 5 indexes you store with them, run it through a single for loop, select your values, compare them all. You think it's going to run like a million times and it's going to be super inefficient. It's really not. Like the most it could ever run is like 5 times, because it's only have 5 different indexes that it's going to be checking, and it's going to be doing the subtraction twice. Not a big deal. It's not going to change anything in your problem. So pretty simple. Thanks for watching, and I'll see you next time.